Okay, so it's recording. I'm sharing the screen. Okay, so we're going to go ahead and start the virtual machine. And then we're going to go read through the PDF just to remind ourselves of the lab that we want to do. So the first one, I assume you guys have no questions on that one. We did the just encrypting things, right? That was the first problem. And the second problem was the image, right? So we encrypted an image with two encryption algorithms, ECB and CBC, and you saw that on one, you could still tell something about the original image, whereas in the other one, you couldn't, okay? I assume this is starting. Okay, here it goes. I'm just going to log in. So obviously we're going to be using the virtual machine here. And then we're going to go to Brightspace and just read through the problem. The third problem should be the one with padding. Okay. So really all we have to do is look at the different sizes. That should be enough. Okay, so let's log in. Okay. We're going to open up the terminal. Right, and we can just navigate to the desktop. And then 350. All right, so this is what we were doing the other day, right? So we have a lot of stuff in here, so I'm just going to create a folder. Call it Symmetric Lab. Okay. Part 2, I guess. That's a reference. All right, so now we can go to the Brightspace environment, go to 350, content. Okay. All right, so this is what we're working on. Let's take a look at the PDF. Kind of read through the description. So remember, you are, we're only focusing on these problems here, right? So we've done this one, just kind of intro to OpenSSL. And we did this one because it's really interesting, the images one, right? There are no questions on these two. Okay, no questions. All right, we can move on then to padding. So this idea here. Okay, so the question is, and you guys, we can work together to solve this, right? Together. So for block ciphers, when the size of a plain text is not a multiple of the block size, padding may be required. So there's a specification called PKCS number 5. It's a padding scheme, which is widely used by many block ciphers. Okay, so we will conduct a few experiments to understand how this type of padding works. Okay, so number 1, use ECB, CBC, CFB, and OFB modes to encrypt a file. So we can pick any cipher that we want, so like AES, for instance. And then please report which modes have paddings and which ones do not. For those that do not need paddings, see if you can explain why. So we'll create 3 files, which contain 5 bytes, 10 bytes, 16 bytes, respectively. The idea is that they're going to be different sizes, basically. We can use something like that to create the files echo-n. The following example creates a file f1.txt with length 5, for instance, right? So pretty self-explanatory. Yeah. Without the -n option, the length will be 6 because the new line character will be added by echo. Okay, so just that's what that's for. And then we can use OpenSSL and code AES-E, just like we did before, to encrypt these 3 files using 128-bit AES with the different modes. Okay, and now, yeah, so let's just try that. That's, good enough. And then we can think of other things. So let's go to the virtual machine. Okay. And in here, yeah. Okay, so here let's do, so it's set echo, right? Echo-n 1, 2, 3, 4, 5. Oops. Double quote. I think it was like that, right? And so all right, so we'll create this file called f1.txt. Everyone with me, guys? Pretty easy, right? So we just create the file, all right? So then ls-l, and it does have size 5. You see that? Right. Okay, we can do this actually. So the problem is set to do 3 of these. So we can do also the other one. So I'm just going to up arrow. And then 1 was supposed to be 10. So then we can just do 6, 7, 8, 9. This one, so 0, I guess, right? So it has 10 characters. But change the name to F2, right? Because we're going to have 2 files. So now we do ls-l, and then we have one that is 5, one that is 10, and then we're going to repeat the same with a third file that has 16, is it? 16, right? So let's change it to F3, and let's do A, B, C, D, E, F. Okay. So we have F1, F2, and F3. One of size 5, one of size 10, one of size 16. You can see the sizes here, right? For each file. Got it? All right, so now we're going to go ahead and try to encrypt these. Okay. So we can take the similar approach that we've taken before. So it's OpenSSL. OpenSSL. Encode -AES 128. And then here, we're going to try the different modes of operation. So we're going to do CBC, ECB, CFB, and OFB. Okay, so let's start with the first one. Let's start with the first one, which is CBC. Like that. Okay, so that's pretty much all we have to do. So -E -in, and then we're gonna I'll do this example for like one of the files, right? And then you guys can do it for all 3, right? So F1, F2, and F3. So I'm currently gonna do it for F1. Is it F1 TXT? Right, so F1 TXT, the name dash out would be F1, and then we want to specify the mode of operation that we use. So in this case, it's CBC dot bin. So remember, we are indeed encrypting this file, right? Okay. So dash out F1 CBC, and then, we can use the same key that we used before. Questions? We're going to use the same key. So 00112223345566778899, and then we had done AABBCC DDEEF, just to be consistent. Okay, so that's the key. And then let's just add the initialization vector for the cases where we need it. And that's going to be 01, 02, 03, 04, 05, 06, 07, 08. Okay, and that should be it, actually. So then I'm going to hit enter. Everyone with me, guys? Everyone? I mean, it's being recorded, so, okay. And it says hex string is too short, padding with 0 bytes to length. Hex string is too long, ignoring X's. Okay, so let's take a look. So we generated from F1 CBC. Do you guys see that? And there's probably padding in there, right? Questions? How do we know? Remember the size. So we did these 3 texts are the inputs. This is the output, and you can see the size there. Any questions? I mean, it's pretty straightforward, right? So this is what, now that file is encrypted, of course, as you know. If we do cat F1 underscore CBC, and you can see it looks encrypted. Okay, so I'm going to do clear. Now we're going to repeat the exercise for, all 4 modes of operation. So we just have to be, we just have to be careful about that one. Okay, so let's see. So now we're going to do OpenSSL encode AES 128 ECB. So we're going to change this ECB, right? And then dash E, dash in is F1, dash out is going to be F1 ECB instead of CBC. ECB.bin. And then here, the key ECB does not need an initialization vector, but it's just going to ignore it, basically. Okay, so it'll probably complain about it. So it's not used by this cycle. Okay, so now ls-l, we have 2 bins now. Notice this one has 16 bytes as well. Any questions? So we've done CBC and ECB, I believe. Yeah. Okay, now we're going to try the other 2 modes of operation. Okay, so I'm going to hit this one. OpenSSL encode. This one should be CFB. F1. Out is F1 CFB. CFB. And then the same key and the initialization vector. Right? Am I missing something? Nope. All right, so it says, it's giving us the warnings, ls-l. We've got a bin file. What's your observation there? Yes, please.
I think it's not padded.
Not padded, right? Because it's the same size. Yes, exactly. Good. Yeah, and so this is basically the idea. So the modes of operation are different. Some add padding, some don't add padding. And this, you can actually literally experimentally observe them. Okay, that's it's not meant to be difficult, right? These are just meant to kind of illustrate or give us insights into the algorithms as we start looking at them. All right, then we're gonna do, so we've done CBC, ECB, CFB. Now we're gonna do OFB. I'm gonna do up arrow here. I'm gonna go back. So this should be OFB. So these are 4 modes of operation. Later we will describe these. Okay, so in particular ECB and CFB, and then also these OFB ones that we have to look at something called stream ciphers instead of block ciphers, and that will give us more intuition of what's going on. Okay. So OpenSSL encode AES 128 OFB -E -in F1 -out F1 OFB, right? OFB. And then we've got the key and the initialization vector. So that should be it. So now we can do ls-l. We've got our 4 bins, and OFB was the last one. What's your observation on OFB?
Still no padding.
Still no padding, right? So you see that. That's exactly right. And that's kind of what you should take screenshots of this in the lab report and make a comment. Okay. Okay, so that's the basic idea. All right, so now you have to repeat this for F2 and F3, right? So that's kind of, I leave that part to you guys. So that's really just because the other ones have 10 bytes instead of 5 or 16 bytes instead of 5. Notice that 1 is a multiple of 8, the one that is 16. So make a note of that. It's intentionally there because it might be that we're using blocks of size 16. Okay. Now we may want to decrypt the file, right? So just to complete the process, so let's take one. So which one do we take? Let's take one of the ones that was padded. So that's, let's take ECB. So let's take a look at ECB here. Or actually, let's do CBC. So up arrow, okay? And we're just going to modify this command to do the decryption now. So it's going to be OpenSSL encode AES 128. I'm going to do CBC, which is one of the padded ones, right? CBC. But now we're going to decrypt, so that's going to be -D. Okay. So we're going to output we want a way to see the padding. So that's kind of what we want here. Like we want, when we decrypt it, we would like to have a way of seeing the padding, right? So I'm going to try something, adding a flag here, dash no pad, okay? And just to, so that it doesn't remove the padding, let's see if I can create a new file, right? So the in file will be not txt anymore, right? It's gonna be F1 CBC, right? Because that's the one that I want to decrypt. F1 CBC .bin, correct? And out will be now a new file. So we're going to do a new txt file, F1 CBC, and hopefully this will retain the padding. So let's give it a name like padded, just so that we can try to visualize that is left in there. .txt. Okay, the key should be the same because we're decrypting. The IV should be the same. All right, so everything looked good, right? Okay, so let's hit enter. Okay, so now let's do clear. Oops, sorry. Clear ls-l. All right, so we've got F1 CBC bin. So let's start with F1. So F1 was 5. Then we had F1 CBC bin, which was size 16. Now we have F1 CBC padded.txt, which should be the decrypted version, right? But if you notice, the size is 16. It didn't go back to 5. Do you guys see that? So it's almost like maybe we did not remove the padding, just intentionally. So let's do cat, and let's try to visualize. So F1 CBC padded txt. Now we can't really visualize anything here, right? This doesn't let us. Let's try nano. Oh, let's just do the same thing. But nano. Add this actually lets us see that the padding was left in there. Do you guys see that? Because initially our file did not have those Ks. It just had nothing. And so this is the equivalent padding. It's probably some hex value. So we might try. So yeah, so this, everyone clear with this one? It's pretty easy, right? Now you have, remember, I'm just doing this for one case. You kind of have to repeat it for all the cases just to kind of get a feel for it. Questions on this one? All right, so this should be the complete exercise. Let's just do one more, maybe see it on a hex basis. So there should be, so I'm going to do clear here. There should be a command that can help us to see it in a hexadecimal formatting. It's xxd. So let's visualize the original file f1.txt first. Okay, so we can see it basically has, it looks like that, right? So the 1, 2, 3, 4, 5, and we've got those values in there. Now, we may not understand what this means, but the padded one should have what? More than this, right? Because there's the padding in there. So let's do ls, the file. So now we're going to repeat this with, which one? F1 CBC padded, right? F1 CBC padded. So I'm going to tab. Okay. All right. So if you look, did I not keep the original one? All right. No, there it is. So here's the original one. 31, 32, 33, 34, 35. So these are probably 31, 32, 33, 34, 35. What do you think those are? Yeah, please. We're seeing it on a hexadecimal basis. So in Nano, you kind of saw it in text, like ASCII. And here we're seeing it in hexadecimal basis. You know what I mean by that? I have a thing though. Let's go to Brightspace. So in Brightspace, I believe I did actually. I provided an ASCII conversions table. Yeah, here it is. So ASCII code hex. Do you see that? So you can click on that one. And this is really nice because it's got the decimal version, the hexadecimal version, and the character. So what were those numbers that we saw? They were, who can tell me? Do you see these numbers? 31. So, you guys are taking a crypto class, so you want to do some cryptanalytics, right? You're looking for patterns all the time. Do you see a pattern here? What is it?
It's the numbers that we made the text file with.
Mm-hmm.
But there's a 3 in front of each of them.
Okay, 30, 31, 32, 33, 34, and 35, right? So, and the numbers were 1, 2, 3, 4, 5, correct?
Right.
Okay, so. I wonder, we look closely at this ASCII table, do we see something? A pattern? Yeah, please.
That 31 is actually.
Yes, in the ASCII table, right? The hex of it, if you look, so the hex of it here for 31, and then it matches to the character, which is 1 on the ASCII table. Do you guys see that? This is not even cryptography. This is just like regular ASCII, and it's already difficult to visualize. So imagine now if you're literally trying to like do crypt analytics, it's even harder. Make sense? Remember that everything is binary in cryptography, and binary is also hexadecimal, right? It's another formatting of it. Any questions, guys? Everyone with me? Guys, any questions? Yeah. You haven't started on which first one?
On the first part of the lab, because I was doing one.
Oh, you okay.
I missed that one.
Okay, I didn't record that one, but that was, we were just encrypting though. So this same command that I'm using with a file, encrypting and decrypting. So I might do it at the end, so just kind of at the end, all right? But pay attention to this part, and I can do that as well, okay? So definitely, well, this is recorded, so hopefully you can just look at it. This is why I'm recording. All right, anyway, so we've completed this problem. That's it. I mean, that's all I want you to do is to kind of get a feel for them, right? So okay, so what do you notice now? When I'm using this XXD program on F1 TXT and on F1 CBC padded TXT. Do you notice that the padding? It's there, right? What is it? This OB. Do you see that? OB, 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 which is that K that we were seeing, right? And that's in hex. So we might want to look for it on this one. I mean, is it in here as a hex? OB? Could be there, right?
On the left here.
Did you find it? Where is it? You think this one, OB? Is that the one? Yeah, it might be. It could be. So yeah, exactly. So it's just some character that's being added by the program. Okay? Any questions? It says vertical tab, so it kind of makes sense that it could be that one. I mean, that's it for this problem. Okay, so you basically just have to do this. Right, but repeat it for all the other files. So F1 is what we did. That was of size 5. And then the other ones are F2 of size 10. And the other one is F3 of size 16. Any questions? Make sense, right? All right, so I'm gonna pause this, and I'm gonna load this video later tonight or tomorrow. But basically just repeat that for F1, F2, F3. And answer the questions, kind of elaborate. Okay, this one has padding, this one doesn't have padding. I was able to observe it and so on. That's all it is. All right, so that one was an easy one. I think the next problem is much more interesting, okay, which is corrupting a file. So I'm going to go ahead, go to the Zoom session here. Okay, stop sharing.